So good morning, everyone. Once again, welcome to Physics by Physics. And in this live session, we are going to discuss some more questions of electronics that has been asked in March 2025 question paper. We have already discussed part B. Now we are going to discuss part C questions. Okay? So let's see. Part B we have already discussed in last session. Now we will see part C. Yes. So let's see this particular question, part C. So first we have to see statement of this question. Now in this question, an LED is required to glow when the temperature sensed by a platinum resistance, this is the platinum resistance in thermometer exceeds a certain value. In the circuit shown below, the resistance of platinum thermometer in ohms varies as this relation. This relation is given how temperature of this resistance varies with temperature, where T is in temperature in degrees Celsius. And this transistor will be on when VB is exceeds 0.7 volt. And it has a very high current gain. So the temperature at which LED would start glowing is closest to approximate value you have to find. So in this case, this LED will glow when transistor is on, means when current will flow through this. When there is a current through this resistor, only then LED will grow. So you have to see at what temperature this transistor will be on. So for that, let's say this is B, this is E, and you should call it as this point as C. So under what condition this transistor will be on? So you require this minimum voltage VBE. So what should be VBE value? So this VBE is given by here base to emitter voltage. Minimum voltage I am taking 0.7 volt. So and this VBE, because VE is 0 here emitter with respect to ground, this voltage is 0. Emitter with respect to ground is 0. So base voltage with respect to ground, this is same as VB. Is it clear? And then if you see, if you draw the equivalent for this particular part, so you have this circuit. Let's see. This part is grounded. This is VB. This is platinum resistance. This is 5K. And this is connected with 10 volt. This is connected with 10 volt and this is grounded plus minus 10 volt. So what will be this voltage? VB. So you should use the voltage divider rule because you have to find voltage across this. So that will be given by simply platinum resistance divided by this is 5 kilo ohm means 5000 ohms plus this resistance into 10 volt. And I'm taking smallest value to be minimum 0.7. So if you solve this equation, you will get the what value of resistance you required for this current to flow. And that will give you the temperature itself. So if you solve it, let's see what you will get. 10 R platinum resistance plus, if you multiply with 0.75 thousand, so this is 3500 plus 0.7 this resistance. Now this will be 9.3 platinum resistance, and this is 3500. And this is in ohms. So if you divide it by 9.3, so if you calculate this value, this is approximately 380 ohms. Approximate value is 380 ohms. Now we will calculate the temperature. What temperature is required? What is the temperature required to have? This is, let's see, this is 380 ohms. Not, this is 380 ohms. So what is the temperature that is required to have this particular resistance so that this current will flow? So from here, you should write it as a 380. I am writing this is in ohms. 100 plus 0.4 T. Now T will be in degree Celsius. So this is 280. And then T will be 2800 by 4. So T you will get 700 degrees centigrade. So approximate value is 700. And if you see the options, approximate value is 700. Yes or no? So option D is correct because others are 400. This is less than this. This is, and this value is very high, greater than even 850. So if you want to have VB slightly greater than 0.7, approximately you need 700 degrees centigrade. Is it clear? So that's why option D is correct. So note it down. So now see, I will solve the next question. So this is first question of part C. Now you will see next question is, yes, this is based on the digital electronics. So simple question, because Boolean expression is given, just simplify it and then you should identify which will give you the correct option. So these questions you can easily solve. So let us see this y, output y is given by first term is A or B. And this, if you write, use De Morgan's theorem, so what you will get? This is A double bar or B bar plus C bar whole bar plus of A bar B plus C. And then you will get y is equal to, this is A or B, this is A or this is B bar, again De Morgan's theorem, B double bar, B complement complement, C complement. So that will give you BC, B double complement, C double complement. And this will be plus A bar B plus C. Now we will take y is, this is A or B, A or B, and this you can write A or B, A or C. A complement B or C. And these two are same, so you should write it as A or B, A or C, A or C, and then A or C, and then A complement B or C. Let's further simplify. So this will give you A and A will give you A. Then you have AC, then you have BA, then you have BC, A bar B, A bar C. Is it clear? So let's see, if you take A, B common, from these two terms, take B common, and from these two terms, you should take C common. So what you will get, A or BC, and if you take A common here, you will get C plus C bar. And if you take B common, A plus A bar. So that will give you A or BC or A or B. Yes or no? Now from these, this is C plus C bar. So that will give you A. And if you take, is it correct? So let's check this. This is A, AC, then you have BA. Here you have A bar B and A bar C. This is BA. Then you have BC. Then you have A bar B and A bar C, because this term is A bar B and A bar C. So what you will get, if you take what you are getting, that one will give you A plus, no. So first term is A, this will be AC, then you have BA, then you have BC, A bar B, A bar C. This point is clear. Now we will take, if you take C common from here, from these two, you have to take C will be common. Yes, let's rewrite this. So I'm taking, this will be A, plus if you take C common, you will get A or A bar. And from here, if you take B common, that will give you A and A bar. And then you have BC here. So this will give you A plus C plus B plus BC. So that is A plus C, B, 1 plus C, 1 plus 1 or C is 1. So this is A or C or B. Or finally, your Y should be A or B or C. Yes. So if you see the option, which one is giving you A? This is A or B or C. No need to check because one option is correct here. So that's why option A is correct. Clear? So it's a simple question. Just try to solve it. Chalo. Now we have next question. I think yes, they have asked these three questions. So we will see. Yes. Now see, in this question, they have given you a circuit here. In the circuit shown below, V1 is given like it has 0.1 sine omega t. And this is sine omega t. superposition of these two. So two different frequencies there. So what we can do when you have to find output, you can use this superposition. Means you can find the output due to individual source, and then you should see the output where omega 1 is this value and omega t2 is this value. The time varying part of the output in voltage, they have asked you closest value, closest to. Now, if you see the option, this is sine omega form, this is sine cos form, this is cos form, and cos sine form. It means even if you can find the what is the phase difference between output and input for signal 1 and 2 for frequency omega 1 and omega 2, you can easily identify the correct options. Okay? So what we will do here, first we will see how to find the phase delay for different frequency for this particular circuit. So let's take the general formula. I am taking this to be R1, this I am taking as RF, and this I am taking capacitance as let's see. So this value is CF, capacitance is CF, and this is RF. So this is in inverting mode. So how you will write VO by V in for any frequency? So this is minus what is feedback impedance. So I am writing it as minus ZF because this resistance is R1. So I am writing it as R1. And what is ZF? ZF is RF parallel combination of XCF. So that is given by RF XCF by RF plus XCF. Yes or no? So this is ZF. So if you divide it by, let's say XCF, so what you will get? This is minus, I am writing here RF by R1, and this is RF by XCF plus 1. Yes or no? I have divided this by XCF, where XCF capacitive reactance is 1 by iota omega CF. Clear? So let's write this value as minus RF by R1 divided by 1 plus iota omega RF CF. Now, whenever inductor, capacitor and resistor combination is given and you have to see the phase relationship. So you have to write output, phase and magnitude relationship. Try to find VO by input in polar form. In complex notation, you have to write. So let's see. Then this VO by V input is given by numerator. I can write RF by R1 exponential iota pi, because cos pi is minus 1. So that minus 1 will be given by iota pi. And this value is given by under root 1 plus omega square RF square CF square exponential iota theta. And what will be theta here? From theta you can write theta will be tan inverse omega RF CF. So now finally you should write this equation as RF by R1 divided by under root 1 plus omega square RF square CF square. So this will give you magnitude of gain exponential iota pi minus theta. So this phase relation is, so this will give you phase is phi is pi minus theta. Phase delay between input and output will be pi minus theta, and this part will give you magnitude of gain. But in this question, because we have to see sine, cos, these terms, so I will just calculate the phi and then we should identify. No need to calculate magnitude. Otherwise, because it's an objective question, So you have to identify the correct option. So that's why focus on only phase angle. So you have to find phase for omega 1 and omega 2. So let's see when omega 1 is 5 into 10 to power 2, this value. So what will be theta 1? Theta 1 will be given by tan inverse omega 1 is 5 into 10 to power 2 into RF is 100 ohm and CF is 2 into 10 to power minus 6. So I think this value will be 10 to power 4 and this is 10 to power minus 2. So you will get tan inverse 0.1. And if you calculate this value in radians, in radians it will be 0.99. So this will give you phase phi 1 is given by for omega 1. Phi 1 is for at omega 1. Pi minus theta 1. Pi is 3.14 minus 0.099. I think this value is this value you should take approximately pi. I am taking approximate value because this value is very small as compared to this. So that's why this is approximately pi. And then because you have to write the closest value, similarly omega 2, when this is for omega 2 is 5 into 10 to power 4. So what will be theta 2? So theta 2 is given by tan inverse 5 into 10 to power 4 into 100 into 2 into 10 to power minus 6. So this will give you tan inverse 10. Again in radian, we are calculating it in radian, and this tan inverse 10, you have to use the calculator. I think this value is 1.47 radian. So phi 2 will be given by pi minus theta 2, 3.14 minus 1.47. This value is 1.64. And you will see that this is approximately pi by 2. So you know phase, what will be phase delay between output and input for omega 1 and omega 2. So corresponding to omega 1, let's say output when frequency is omega 1, corresponding to this output is V01, that will be proportional to sine pi minus omega 1 t, and this will be proportional to sine omega 1. So you have to focus on the proportionality only, and when you have omega 2, corresponding output will be proportional to pi by 2 minus omega 2t. So this will be proportional to cos omega 2t, and that's what you have to identify whether you are getting sine and cos term. So I think sine and cos, just identify sine and cos because it's an objective question. So you have to identify the correct option. So that's why I am just calculating this. If you calculate for calculation purpose, you can find the magnitude also by using this relation. Is it clear? So these are the 3 questions that has been asked in part C in March 2025 paper. So I think all these 7 questions are direct questions and you can easily solve it. Clear? Chalo. So in next lecture, we are going to solve the EMT question of March 2025. Okay? Okay. Thank you. Thank you everyone. Thanks for watching.